Okay, good evening. Um, as I had promised you before, I want to start a short series of a series of short videos on the basics of the chemistry that you will need to understand some concepts in this course. I understand it is difficult for some of you to transition from the organic chemistry and the chemistry that you have learned many years ago all the way to polymerization reactions, arrow pushing, et cetera, et cetera. And so some of you are not chemical engineers either. So I have been getting some feedback saying that is there any kind of help to understand some of the chemistry parts? So I thought I should just make some short videos. So let me start off with the very basics. So it will be a different kind of a series of introduction to bonding because it will be related to what we are going to do in the course. So it will not be the same bonding exactly the same bonding lectures that you had in the past. So I'll try to teach it kind of innovative way of doing it. Hopefully it'll work because I have to do it quickly because this is a very short introduction to bonding and then move on to covalent bonding and then to arrow pushing and then reactions, etc. So it's a huge chapter. So I'm trying to cover in 4 short videos. So hopefully it works. If not, you can go back and do it again. So with that, let me share screen and see what we can do. So, all right, what we want is bonds, right? Bonding basics all the way to arrow formulism, right? So that's what we are trying to do from bonding basics to arrow formulism. That those of you who've taken organic, you know what I'm talking about, right? Bonding basics is what is A plus B giving you A, B, right? There's a line between A and B, that's a bond, right? What the hell does that really mean? All the way to how do you get aniline to oxidatively polymerize to polyaniline. This is polyaniline, okay, X. So 4 of these aniline units. So how did this happen? This looks like magic, right? So this is easy, this bond. But how do you get this to marry with that? How do you understand this? If you don't understand this, you don't know how the synthesis is. So therefore, how can you make it change its structure to affect its electronic properties, right? That's the idea. So let's start off with some. So I'll try to keep these videos short in short bursts. There'll be multiple videos. So let's start off with bonding, okay? Why do two things bond, right? In chemistry, things bond because there's an exchange of stuff, right? You give me stuff, I give you stuff. I give you wheat, you give me rice, right? That's a kind of a bond, straight bond. In chemistry, in chemical engineering, in materials in general, bonds occur because of exchange or trade or sharing of electrons, okay? So that's what happens. So if you have two things, A and B, A has a lot of electrons, B has a lot of electrons. And when we say A forms a bond with B, this line means there are 2 electrons. There are 2 electrons that somehow in a single bond or in one exchange, let's call it a single exchange. You don't even have to call it single bond, exchange. So the first concept is there is no I give you wheat, you give me rice. There's no such thing. There's just one exchange. Something that wants to give up its electrons, gives it to something that wants electrons. Okay. So this is a desire fulfillment, right? Bonding is nothing but desire fulfillment amongst molecules. Okay, so let's take an extreme example, right? Let's take an extreme example in the periodic table. Okay, you have on the left hand side, you have metals that want to give off electrons. They don't like them. Okay, they're very unstable. Sodium is very unstable. It'll burn your hand if you take some sodium in your hand, it'll burn it. But if it gives off its electron, it becomes sodium plus, becomes stable salt, right? You can drink it, you can eat it, nothing is going to happen. So it wants to give off its electrons. Similarly, chloride here, chlorine, Cl is chlorine, will burn you to death because it's an actual gas that was used in warfare, right? But if it gains an electron, it becomes chloride. And that's full of seawater is all chloride, right? It's just salt. So this side, folks on this side want to give up electrons to become stable. Folks on this side want to take up electrons to become stable. So that's a form of an exchange, right? It's a win-win situation. So in the case of sodium, sodium gives off an electron to become sodium ion, right? And chlorine plus an electron becomes chloride, right? So this together, they give you, of course, here, Dr. Manohar, come on, this is just junk. I learned this when I was in, whatever, 8th grade, right? No, the question for you is, when they do react, is there a line between sodium and chloride? Do we call it this? After all, a bond means sharing of electron, right? No, right? There's only one electron. There are no two electrons, only one electron. So there's no line, no line. So how do you depict sodium chloride? You call it Na plus Cl minus, right? So this is called an ionic bond, right? There is no line, there's no sharing. It's just selfish donation and takeover, right? So then why is there a bond if this is taken away? Because this is like a battery, right? This is like a kind of like a battery. The minus and a plus, right? So in a north and the south pole of a magnet, they're together. They always go together, right? So that's the being togetherness creates a bond, and that bond is called an ionic bond. Okay, it's called the electrovalent or ionic bond. Bonding, right? That's one kind of bond. Now comes the the fun part, right? What if the two materials that want to form a bond are not from the opposite poles of the periodic table? Now comes to some definitions. This wants to give off electrons. Sodium, lithium, this side wants to give off electrons, right? These are called electropositive elements because they want to become positive. These want electrons, so they're called electronegative elements. And the desire for electrons has a term called electronegativity. If you want more electrons, you're more electronegative. So electronegative negativity increases as you go from left to right in a periodic table. Okay, so these elements want to be negatively charged. So okay, that's one thing. What if you don't want the two atoms that want to form bonds end up being in the same side? Here, chlorine and chlorine says, wait a minute, we got to form a bond because we're extremely reactive by just Cl, right? We want to come together. How is that even possible? Same electronegativity. So the question is, what if A and B are the same? What happens then? Chlorine and chlorine, right? what it does. See, chlorine has 7, right? 1, 2, 3, 4, 5, 6, 7 electrons. 1, 2, 3, 4, 5, 6. It's the outer shell, okay? What it says, all right, you don't want to give off, I don't want to give off my electrons. We are just equal, right? We're just like twins. But if we can share these 2 electrons equally, then we'll have a total of 8 on each side, right? There's 8 here and 8 here. So that's an octet. So you can form a stable octet on both atoms. That's a driving force, right? Even though they don't want to give off electrons, if they share electrons, so this is a true sharing, right? I give you wheat, you give me rice kind of stuff. I give you 1 electron, you give me 1 electron. In this case, you're going to have Cl, Cl, right? But here, there is a line. You have to draw a line. That's called a covalent bond. There's an actual line. There's no real line. It means what? What does the line mean? That means the 2 electrons are shared right smack in the middle, right? You have chlorine and chlorine. The 2 electrons, well, there are 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So the 2 electrons are smack in the right center. So this is a covalent bond. Okay. Similarly, hydrogen has 1 electron. This hydrogen has 1 electron. They come, it's very unstable. So let's share. So these 2 become, when they share equally, this becomes a H, and the 2 electrons are shared in the middle. This is hydrogen molecule, right? So atoms become molecules. And there is no real transfer of electrons. This is a sharing of electrons, and the 2 electrons live in the middle. And because they live in the middle, we don't call it live in the middle. We just draw a line. In bonding terminology, a line means these 2 electrons have made a home in the middle of the 2, geographically in the middle of the 2 atoms, center of the 2 atoms. Okay, that's a second concept. Concept number 3 in bonding. What if these 2 are not identical, but something like hydrogen and oxygen? Well, then what? Right? It says 1, 2, 3, 4, 5, 6, 7, right? This has just 1. So these 2 come together and say, if we kind of, we can have this kind of a stuff. 1, 2, 3, 4, 5, 6, 7. The 7th comes from the oxygen, and the 1 comes from the hydrogen. Said, well, what about, that's a sharing, right? OH bond, sharing, right? But here's the complication. Hydrogen is all the way over here, right? Oxygen is there. But it's not fluorine. So it's still not it doesn't take all the electrons to itself and become H plus or minus, right? It does not become H plus or minus, but instead it stays there. But where do you think the electrons will be? Will they be smack in the middle? Or what? This is a very important concept. So the electrons are pulled towards the oxygen, right? But it's not enough, it's not strong enough a magnet to become minus. So what it does is that you still use the bond, you still use that line. The electrons are shared almost very close to the oxygen, both the electrons. Because of that, because it sucks the electrons to the side, this becomes minus charge, this becomes a plus charge, okay? Not real plus, but it's a delta plus. These types of bonds where the electrons are shared, but the sharing is kind of on one side, they're called polar covalent bonds. Okay. The polarity of the bond is the magnitude of the polarity depends on how negative the negative one wants to take the electron. Okay. If it's too negative, it takes the whole electron and becomes an ionic bond. Okay. So that's the difference between an ionic bond, a covalent bond, and a polar covalent bond. Okay. So I'm going to stop this video here and then move on to the next concept, because otherwise these videos get ridiculously long and you'll never even watch them.